بسم الله الرحمن الرحيم. السلام عليكم ورحمة الله وبركاته. Math grade 8. We are in model 5, lesson 6. The last lesson in this model, qualitative graphs. Qualitative graphs. In this lesson, we want to recognize a quantitative graph and interpret the scenario it represents, as well as create a qualitative graph. So in this lesson, we want to learn analyze qualitative graphs. Analyze qualitative graphs. The graph shown is a qualitative graph. So a qualitative graphs are graphs used to represent situations that may not have numerical values, or graphs in which numerical values are not included. As you see in this graph, here we have times in x-axis, and here we have downloaded percent in y-axis, and here we have the graph. For the time and for the downloaded percent, axes are labeled, but don't include numerical values. And as you see here for the graph, you can see the relationship between time and percent of photos downloaded. The rate of change of qualitative graph can provide useful information between two values. As you see in this graph, here we have linear, and the linear go up. From here means increasing at a constant rate. Increasing at a constant rate. In the second graph here, as you see, we have linear but go down. So here means decreasing at a constant rate. And here, as you see, we have line parallel with x-axis. So it means here no change, not increasing and not decreasing. This is fixed line. This is parallel with x-axis. So it means here no change. Here, as you see, we have curve. But this curve go to the up, means increasing at a varied rate. And here we have curve go down, means decreasing at a varied rate. For example, analyze qualitative graphs. The graph displays the water level in a bathtub. Describe the change in the water level over time. The time and y-axis the water, and we have here the graph. In this period here, we have, as you see, increasing. In this period here, no change. In this period here, we have decreasing. So the graph demonstrates how the water level changes as time increases. So the water level increases at a constant rate for a period of time. There is no change in the water level. Then the water level decreases at a constant rate. In this example, as you see, the graph represents revenue from a local clothing store. Describe the sales over the time. As you see here, x-axis the time and y-axis the sales. And here we have the graph. As you see, the graph not straight line. We have many periods here. Here we have period, here period, here period, like this. but the line, as you see, go up. So overall, the cells increase. The cells increase steadily. There are two periods of time where the cells decreases. As you see here, this period decreases here, or remain constant. And here, as you see, we have constant. In this period, we have constant. In this period, we have decreases. The second idea, sketch qualitative graphs. Qualitative graphs represent essential elements of a situation in a graphical form. You can sketch qualitative graphs to represent many real-world functions that are described variable. Charlie's speed over time. Charlie is riding his bike. He speeds up, rides at a constant rate, then slows down. So as you see in this graph, we have x-axis the time and y-axis the speed. As you see in this period, we have increase, here no change, here we have decrease. Number of pencils sold over time. A school store sells pencils. At the beginning of the year, they sell a lot of pencils. Then sales drop, and finally pencils are sold at a steady rate. Sketch a qualitative graph to represent the scenario. As you see here, we have x-axis the time and y-axis number of pencils sold. So as you see here, we have increase, decrease, then no change. Sketch qualitative graphs. A tennis ball is dropped on the floor. On each successive bonus, it rebounds to a height less than its previous bonus. High unit, it comes to rest on the floor. Sketch a qualitative graph to represent the situation. Determine if the graph is linear or non-linear and where the graph is increasing or decreasing. So the first step here, sketch a qualitative graph to represent the situation. Draw and label the axis. Label the vertical axis, distance from floor. Label the horizontal axis, the time. As you see here, draw x-axis, represent the time, and draw y-axis, represent distance from floor. Then, sketch the shape of the graph. The distance from the floor starts out at a high value, then falls to the floor. The ball bounces and rebounds to a high less than its drop height. This pattern is repeated several times until the ball comes to rest on the floor. So as you see here, we have the graph. So means here we don't have linear. As you see, we don't have linear. Here we have non-linear. So determine if the graph is linear or non-linear and where the graph is increasing or decreasing. Is the rate of change in the graph constant? No, we have change. So the graph is non-linear. The graph is increasing. As you see here, decreasing, increasing, decreasing, increasing, etc. Whenever the tense pole travels up in the air, because the distance from the floor is increasing, the graph is decreasing. Whenever the tense pole travels toward the ground, because the distance from the floor is decreasing. As you see, the distance from this point to this point, then here we have the distance from this point to this point, then here the distance from this point to this point, and here also, and here also. As you see, we have from this point to this point, to this point, to this point. As you see, we have what? We have decreasing. We have decreasing for the distance from the floor to the air. We have decreasing. A person riding a bike slowly decreases their speed, then they quickly speed up. Finally, they maintain a constant speed for a period of time. Sketch a qualitative graph to represent the situation. Here we have x-axis, the time. Here we have y-axis, speed. As you see, the speed here decreasing, then increasing, there no change. Determine if the graph is linear or non-linear, and where the graph is increasing or decreasing. So as you see, this is not linear. The graph is non-linear. The graph is increasing when the bike speed up. Here, when the bike speed up means we have increasing in this period. The graph is decreasing when the bike slow down. When the bike slow down in this period. Sketch qualitative graphs with values. Lewis is biking to his friend Nathan's house. He increases his speed at a constant rate of 2 minutes until he reaches a speed of 6 miles per hour. He then decreases his speed at a constant rate for a minute until he reaches a speed of 2 miles per hour. Finally, his speed increases at a varied rate for 3 minutes until he reaches a speed of 8 miles per hour. Sketch a graph that accurately represents Lewis' trip. Draw and label the axis. Label the vertical axis speed meter per hour. Label the horizontal axis time using minutes. Use the information in the problem to sketch the shape of the graph. As you see here, we have x-axis represent the time using the minute, and y-axis represent the speed using meter per hours. And as you see, we have this is the graph. So from the graph, this is not linear or non-linear. As you see here, we have increasing, decreasing, increasing. So Julian is riding his horse. The horse speed increases at a constant rate of 2 minutes until it reaches a speed of 10 miles per hour. Then it increases his speed at a varied rate for 1 minute until it reaches a speed of 20 miles per hour. Finally, the horse decreases its speed at a constant rate for 3 minutes until it comes to a stop. Sketch a graph that accurately represents Julian's horse ride. As you see, here we have x-axis, the time using the minute. Here we have y-axis, represents speed using meter per hours. Here we have increasing in constant rate. And here we have increasing in varied rate. And here we have decreasing. Here we have decreasing in constant rate. So this is our lesson for today. Who has any question about this lesson? Are all ideas clear for all? No questions, girls? Okay. Tomorrow, inshallah, we have math quiz, just in Model 5. We have 6 lessons in the same period of the mathematics, in the same period and in the same time. So let us to go to the some practice about MSAT. Then we have this exercise. I want from all to read this exercise. Then please tell me what is the correct choice from the 4 choices here. Start, please. Okay, who can answer me here? Where are you girls? Are you hear me? Latifa, Beka, Taif, Afra, Aliazia, are you hear me? Where are you girls? Are you hear me? As you see here in this example, here we have 2 over 5. Is it 2 over 5 equal 40 over 100? You can do here simplest form. You can here divide by 20 and divide here by 20. So 40 divided by 20 will be 2, and 100 divided by 20 will be 5. So here 2 over 5 equal 2 over 5. So this is here correct. Here, is it 2 over 5 greater than 6 over 9? We can divide here by 3, and we can divide here by 3 to know the simplest form of this fraction. So 6 divided by 3 will be 2, and 9 divided by 3 will be 3. Is it 2 over 5 greater than 2 over 3? When you have two fractions and you want to compare between them, and inside the two fractions you have the same numerator, here we have 2, here we have 2. You can compare between the denominators. The small denominators means the big fraction. The small denominators means the big fraction. So this sign not true. This sign not true. The right sign 2 over 5 less than 2 over 3. So this choice wrong. Number C, is it 3 over 5 equals 75 over 100? We can here divide by 25 and divide here by 25. 75 divided by 25 equal 3. 100 divided by 25 equal 4. Is it 3 over 5 equal 3 over 4? No. So this is wrong. Is it 2 over 5 greater than 2 over 3? As you see here in the two fractions here we have the same numerator. So you can compare between the denominators. The small denominator means you have the big fraction. So means 2 over 3 greater than 2 over 5. So this sign not true. 2 over 5 less than 2 over 3. So this is not correct. Do you have any question about this idea, girls? Latifa, are you hear me? Taif, Afra, Aliazia, are you hear me? طيب. Remember me tomorrow, inshallah, or in the next week. In the next week, we have this problem. We want to solve it together. So, inshallah, in the next week, on Monday, on the next Monday, we have math quiz, just model 5, 6 lessons, in the same period of the math. So this is our video for today. Thank you for your listening. Have a nice weekend. See you inshallah on next Monday. Assalamu alaikum wa rahmatullahi wa barakatuh.